In my last video, I discussed some tips about making satisfying animated loops, but in this video, I'm going to focus on infinite scaling loops in depth. Specifically, I'll cover all the math involved in making infinite scaling loops work perfectly. I'll be explaining how to use the formulas, but don't worry, because you won't have to do any math. Everything is set up using drivers and scripts, and I've set them up to be easy to use, I promise. I'll show you how to prevent the loop from starting fast and then going slow. I'll show you how to find the point from which to scale from, as well as how to prevent the so-called bouncing effect. I'll be giving you a script that calculates the center, along with some .blend files that are set up so you can start making your own today. So if that's something you're interested in, buckle up because you're in for a treat. Infinite scaling loops work by having an initial object I'll call the root. It's located at the origin, has no rotations, and a scale of 1. A second object is created that I'll call the parameter object, and it's translated, rotated, and scaled. I'll call these the parameters of the parameter object. Then the next object is positioned in a similar fashion based on those parameters. The rotation is optional. If you choose not to rotate, then you're working in one dimension, as seen in this example, so don't think 1D equals boring. 2D is when we rotate along one axis, and 3D occurs when we rotate along more than one axis. Then this structure is scaled, either up or down, by the original scaling factor, and then rotated into place if necessary. This leaves you with an identical structure, but each object is in the place of another object. When the transition between these structures are animated, it gives the illusion of a seamless loop. That's the gist of it. Now I'll be going over how it works in different dimensions. You don't have to follow along, and I recommend that you don't. Let's say we have a square and it's 2 meters and one of the vertices is on the origin. Now I'll add an empty and rename it to parameters. Then I'll add an array modifier to the square. I'll disable relative offset, enable object offset, and select parameters. Then I'll move parameters over by 3 meters and set the scale to 0.1. This 0.1 number is what I call the scaling factor. It is very important to these animations and common to all dimensions. Once you decide on a scaling factor, it's most likely going to remain the same for the duration of the project. If we increase the count on the array modifier, you'll notice that they converge to a point. This point is what I'll call the scaling center, and it too is very important and also common to all dimensions. This is where the whole scene scales from. The expression to find the center in 1D is distance divided by 1 minus the scaling factor, where the distance is how far you move the parameters over. I've set it up in the .blend file already. You just have to play with distance and the scaling factor, and Blender will calculate the scaling center for you. This can be done on all 3 axes. I can't think of a use case for that, but the .blend files are set up for it in case you need it. Now when I say 1D, that's only because it works on things that are in a line, aka one dimension. The things themselves can be whatever dimension you want, 2D or 3D. Like these squares here are 2D, but this would work just fine if they were cubes or spheres. Now that we have our scaling factor and our scaling center, we can animate this. That's all we need to know since we're not dealing with rotations. To animate it, first apply the array modifier on the object, and then parent the object to the spiral center. Set a keyframe on the spiral center's scale. Then on the last frame, set the scale to 1 divided by the scaling factor. You'll notice that it explodes at the beginning and then slows down gradually towards the end. Your initial intuition may tell you to set the animation to linear to make it scale at a constant rate. However, this still doesn't fix the problem. To fix this, you have to use this formula. Now, before you say, screw that, I'll work at Burger King instead, I'm going to show you how to use it. First, copy the expression from the description. Then delete your keyframes and add a driver. Paste the expression under expression, and go ahead and delete this variable. The expression in this form will cause your objects to scale outward. If you want them to scale inward, all you need to do is remove this 1 over part. The number of iterations is how many objects it hops over before it loops. For example, at 1, the second object will go to the first object. At 2, the third object will go to the first object, and so on. Animation length is obviously the length of your animation. It's set up so you don't have to subtract 1 from the end frame, so it doesn't stutter for a frame. Frame is just a built-in Blender variable. If you're not using Blender, your 3D software probably has something similar. And finally, start frame makes the animation start on something other than the first frame. Then you would add all the variables as seen in this image, but this has already been set up for you in the .blend files. The start and end time on your timeline can't be set up with drivers, but they are set up using a script. Luckily, this expression is common to all dimensions. If you're making a lot of these types of loops, you're definitely going to use it. That's all the math you need to know when working in one dimension. Everything else is up to your creativity. 2D is where things starts to get interesting. It occurs when we introduce a rotation on a single axis. Finding the center becomes more complicated, but again, the .blend files are set up for you so you don't have to do anything else. The formulas for finding the center in 2D are too complex to explain in this video. They look like this. I know, right? If you're interested in how this was derived, I've left links in the description. They're unfortunately not that detailed. Once we introduce rotation, there's a few interesting things to note. If we rotate by a number that goes evenly into 360 degrees, then we can set the iteration to 360 degrees divided by the angle you rotated. This gives you a whole number and the spiral won't have to rotate at all to get to the next iteration. For example, if I set the parameters rotation to 120 degrees, it'll repeat every 3 objects. 1, 2, 3, and then this fourth object has the same rotation as the first, except it's scaled down by the scaling factor raised to the 3rd power. That means if we scale the whole spiral up by 1 over the scaling factor raised to the 3rd power, then the 4th object will go to where the first object was, making a seamless loop. If you set the number of iterations to 3 and enable simplify, the formula will handle this for you. If the rotation exceeds 180 degrees, you can actually simplify this by doing some modulus math. So instead of rotating over 180 degrees, it'll go straight from here to here. In this demo, both are rotating to the 5th iteration, but the one on the right is taking the shortest route. This is what happens when you turn on Simplify. 3D is a new frontier. There are already artists experimenting with it, but from what I can gather, no one knows how the math works. What they typically do is rotate the spiral center by the original rotation, but inverted. So if they rotated 10, 20, and negative 30 degrees on the parameters object, they would then rotate negative 10, negative 20, and positive 30 degrees on the spiral center after the spiral is parented to it.
So we'd need to animate that arc to make it perfect. I'm not going to do that. Instead, what we can do is we can do a cheap trick. So instead of linear interpolation, I'm just going to take this and set it to bounce.
To make it smooth, the spiral center's rotation has to match the parameter's rotation axis. Then it needs to be set to axis angle, and when the W axis is set to 0, then it undoes the original rotation. I've left a README file in the .blend files in case there are any confusion. However, if you still don't understand, drop me a comment and I'll try my best. Some of the .blend files have more bells and whistles than I've mentioned. For example, in 1D, you can do things like invert the scale axis, which can lead to some interesting results. I haven't figured out how to do that in 2D or 3D yet, but if you or someone you know could let me know, that would be great. After you get something nice, you can add mirrors or duplicate it or rotate it. I've kept my objects simple so you can see what's going on, but you can add tons of details to really make them stand out. If you don't feel like learning how to use the different setups, then just know that the 3D scene can handle 1 and 2D. If you end up making something cool with what you learned, I'd love to see it. You can message me here or send me a DM on any of my social media accounts. Links are in the description. Likewise, if I didn't explain something well enough, leave me a comment. So far, this video was the most expensive to make, and I don't expect anything back, but I would appreciate a like if you learned something new, and a sub if you want me to keep making videos. That's it for this video. Thank you so much for watching. I hope you learned something. Have a good one, and take care.